Okay, next example. On Blackboard and on the internets, you can find inertia for basic geometric shapes like rectangles, triangles, circles, okay? And we can use those already calculated inertia to find composite body inertia. So for example, let's have x in inches here, y in inches up here, and we will have a rectangular shape. Okay, so I'm going to cross you at 4, and you at 10, and you at 8. So here's my area. And I want to find Ix, Iy, Ix prime bar, Iy prime bar. All right. Now using composite body method, I found that the centroid here is located at 3.714, 3.714, and 3.428. Okay, so both of these are found using the composite body method for centroids that we discussed in lecture 22. All right. For rectangle, Ix will equal base times height cubed divided by 3. Iy will equal height times base cubed divided by 3. For the triangle, Ix is equal to base times height cubed divided by 12, and Iy base times height cubed divided by 12. Okay, for the x direction, Ix, we can simply sum up our rectangle and triangle because they are both touching the x-axis here, right? Both touching x-axis. All right, so I can use their equations for Ix and, Ix, just Ix. So that's going to be base of 4, height of 8 for my rectangle, cubed divided by 3, plus my triangle, which has a base of 10 minus 4, which is 6 times 8, cubed divided by 12. And this is equal to 939 inches to the 4th. Okay, so now that we know that, we can use parallel axis theorem, and we have 939 inches to the 4th is equal to Ix prime bar plus our area. Oh, I haven't done the area work yet. So that is a rectangle 4 times 8 plus 1/2 of 6 times 8. So there's my area. And then the distance I want to travel, so if I'm going from x to x prime, that's going to be the 3.428 inches squared. And this will give me and Ix prime bar of 281 inches to the fourth. All right, now I did those two first because everybody's touching the x-axis and it makes it lovely, okay? And just to reiterate, this is what I'm calling the x prime axis from the centroid, and this is the y prime axis. Now, less lovely is my triangle here is not touching the y-axis. It is off the y-axis by 4 inches. So we are going to have to do things a little bit differently to get it to the y-axis. Okay, so let's just use red still. If I have this triangle here, it has its own little personal centroid here, centroid triangle. Okay, and I need to get it over here to the y-axis, distance x triangle, okay, using parallel axis theorem. And looking up my shapes, I find that y prime bar for the triangle is equal to height times base cubed divided by 36. Okay, then the bar's there because this is centroidal. So, using parallel axis theorem, y for the triangle is equal to 8 times 6 cubed divided by 36. So there's my centroidal, plus the area, 1/2 base times height, times the distance I want to travel. So that's going to be 4 inches plus 1/3 of 6 inches to get it all the way back there to the y-axis. Okay, and let me label things. So this is I bar, this is the area, and this is dx triangle as I have it labeled up there. Okay, oh, squared. Good job, me. Squared. And this is going to be equal to 2, 7, 8, 9, 10, 11, 912 inches to the fourth. All right. So that is the moment of inertia of just my right triangle about the y-axis. So now y will equal the rectangle, which is touching the y-axis. Okay, so that is 8 times 4 cubed divided by 3 plus 912. And that's going to equal to 1,080 inches to the fourth for my moment of inertia about the y-axis. Okay? So we needed to use parallel axis theorem for the right triangle because it was not touching the y-axis. The rectangle was touching the y-axis, so we did not need parallel axis theorem. Now that I have the composite body's moment of inertia about the y-axis, I can use parallel axis theorem again to get the centroidal. So IY is equal to IY prime bar plus ADX squared. And that's going to be 1,080 inches to the fourth is equal to IY prime bar plus area. We found that earlier to be what, 56? 56 inches squared for the entire shape, rectangle and triangle. And then my distance x, which is the 3.71 inches, quantity squared. And we find that our centroidal moment of inertia for the composite body about its own centroid is 310 inches to the fourth.